Rational Numbers, Lesson 1.1. The standard is 8NS1. The objective is to write fractions as decimals. The essential question, why is it helpful to write numbers in different ways? A square number is a number with a perfect square root. For example, numbers 4, 9, 16, 25, 36, 49, 64, 81, 100. A square number can end only with digits 0, 1, 4, 6, 9, or 25. Rational numbers. A number is rational if it can be written as a fraction. It includes decimals repeating in a pattern. Some examples are 6, 0, 1/3, -4/5, the square root of 25, the square root of 100, 3.222, and -0.1212 repeating. Those are some examples of rational numbers. Irrational numbers. A number is irrational if it cannot be written as a fraction. It includes non-terminating decimals without a pattern. A famous irrational number is pi. Another irrational number is the square root of 5 because it is not a perfect square. Same with the square root of 12 because it is not a perfect square. Another irrational number would be 6.2143, and it goes on forever, but it's not repeating. Another one would be -0.5142, and it goes on forever, but it's not repeating. Those would be examples of irrational numbers. Convert fractions to decimals. Think of division. Divide the numerator by the denominator. Use a strategy in and out, just like the hamburger joint. Example number 1. Write the fraction as a decimal. So I'm going to use the strategy in and out. So 3 is going to go in, and 4 is going to go out. So 4 cannot go into 3, so I'm going to put a 0 up top. I'm going to add a decimal and another 0. 4 can go into 30, 7 times. 7 times 4 is 28. So when I subtract, 30 minus 28 will give me 2. I'm going to bring down another 0. 4 can go into 20, 5 times. So 5 times 4 is 20. When I subtract, that gives me 0. So my answer is 0.75. Example number 2. Write the fraction as a decimal. So again, I'm going to use this strategy in and out. So 2 is going to go in, 9 is going to go out. And 2 is the one that goes in because it's the first number I see. So since it's -2/9, that means my answer is also going to be negative. 9 cannot go into 2, so I'm going to put a 0. I'm going to add a decimal and another 0. 9 can go into 20 2 times. So 9 times 2 is 18. 20 minus 18 will give me 2. I'm going to bring down another 0. 9 can go into 20 2 times. 9 times 2 gives me 18. 20 minus 18 will give me 2. I'm noticing that this is going to repeat. It's going to go on forever. So that means my answer is going to be -0.22 repeated. Example number 3. Write the mixed number as a decimal. So again, I'm going to use this strategy in and out. So since I have a whole number, that means my answer is going to be 4 point something. So all I have to do is divide the fraction. So 13 is going to go in, 25 is going to go out. So my answer is going to be 4 point something. I'm going to add my decimal and my 0. So 25 can go into 135 times. 25 times 5 will give me 125. I'm going to subtract. 130 minus 125 will give me 5. I'm going to bring down another 0. 25 can go into 52 times. 25 times 2 will give me 50. I'm going to subtract. 50 take away 50 will give me 0. That means my answer is 4.52, or 4 52/100ths. Example number 4. Write the mixed number as a decimal. So again, I'm going to use the strategy in and out. So since I have a whole number, that means my answer is going to be 3 point something. So all I have to do is divide the fraction. So 1 is going to go in, 11 is going to go out. And I'm going to have 3 point something. I'm going to add my decimal and my 0. 11 can go into 10 0 times. 11 times 0 gives me 0. I'm going to subtract. 10 minus 0 will give me 10. I'm going to bring down a 0. 11 can go into 100 9 times. 11 times 9 is 99. I'm going to subtract. 100 minus 99 will give me 1. I'm going to bring down another 0. 11 can go into 10 0 times. So 0 times 11 will give me 0. I'm going to subtract. 10 minus 0 gives me 10. I'm going to bring down another 0. 11 can go into 100 9 times. 9 times 11 gives me 99. I'm going to subtract. 100 minus 99 gives me 1. I notice a pattern being repeated here. So that means my answer is going to be 3.09 repeating.